afternoon. Am I audible?
Yes, sir, audible.
So yesterday we have completed the ordinary differential equation part. After that, we have started the partial differential equation. In the partial differential equation, we have two subtopics. One is classification, other one is solution of a differential equation. Out of two subtopics, classification and solution of PD, classification part is also completed on. Classification is very simple. Even if we get any question on partial differential equation topic in future, you will get question on classification. Just the second order linear differential equation will be given. It will be asked to write the type of the equation. That equation may be either hyperbolic or parabolic or elliptic. That depends on the b square minus 4ac only. Greater than 0 hyperbolic, less than 0 elliptic, equal to 0 parabolic. That's all. Just we have to express the given equation in standard form, and then we find a, b, c. After that, we check the condition b square minus 4ac. Based on that, we write the name of the equation or type of the equation. Right? With this last class only. So up to here, we have completed the classification of second order linear partial differential equation, because classification is only for second order linear partial differential equation. Next, other part of the partial differential equation is solution of a PD only. So let us start the solution of PD. Today's class is the last class for the differential equation topic. Already I told you that from the partial differential equation, there was no question for EC branch. Only for instrumentation, there was a one question on partial differential equation for instrumentation. But in the IES examination, we have only 4 years question papers: 2017, 2018, 2019, 2020. Only 4 years papers. Out of 4 years papers, we have the 4 questions from the differential equation topic. The 4 questions were given on the differential equation topic in the IES examination only. Out of 4 questions, the 3 questions are partial differential equations only. Only one of the question is on ordinary differential equation. That too, the ordinary differential equation question was given in the recent year 2020 paper. In the 2017, 2 questions were given on partial differential equation. In the year 2018, no question from the differential equation topic. From other topics, questions were given only. In the year 2019, 1 partial differential equation only. So there are 4 the previous year's question papers on differential equation. Not on differential equation. For IES examination, we have 4 years question papers. From the 4 years, we have the 4 questions on differential equation. Out of 4 questions, 3 questions were given from partial and 1 question was given on ordinary. We do all this also. Okay, let us start today's class. Solution of a partial differential equation. Second subtopic of partial differential equation is solution of a partial differential equation. In this, we'll discuss about the method of finding the solution of linear homogeneous and also method of finding the solution of non-linear partial differential equations. First we start with the solution of homogeneous linear differential equation. That may be first order or second order. And for this solution of first order or second order homogeneous linear differential equation, there is a common method, that is method of separation of variables. Solution of homogeneous linear partial differential equation by method of separation of variables. So first, we discuss about the method of separation of variables. This is the method to find the solution of the homogeneous linear partial differential equation. This method is applicable to only for homogeneous linear partial differential equation. Right. Now, before going to discuss about this method, just look at this. dy by dx plus y into e power x plus d square y by dx square equal to 0. It is an ordinary differential equation. Highest order derivative second order. It is a second order ordinary differential equation. Already we know the method of finding the solution of first order and second order, third order, fourth order equations. It is a second order linear ordinary differential equation. Finding the solution of this equation, finding the solution of this ordinary differential equation is same as finding the relation in terms of independent variable and dependent variable. If it is ordinary differential equation, it will contain two variables. The solution is same as relation between the independent and dependent variable. Let us suppose that is y equal to f of x. This is a solution of the differential equation. Because solution means relation between the variables and satisfying the differential equation. In the same way, for partial differential equation also. Dou square u by dou x square plus dou u by dou x plus u equal to u square like this. It is a partial differential equation, or here dou u by dou y. This is a partial differential equation, that to second order partial differential equation. In this equation, three variables are present. One is dependent variable u, other independent variables are x and y. If it is partial differential equation, then the differential equation contains more than two variables. Out of all the variables, one of the variable is dependent variable, other variables are independent variables. So here, like above equation, to find the solution of this equation, you have to find the u in terms of x and y and satisfy the equation. For ordinary differential equation, solution is same as relation between independent and dependent variable. For partial differential equation, the solution means relation between relation among the three variables u, x, y, satisfy this equation. Right? Just remember this one. Now, first we read the method of finding the solution of the differential equation by separation of variables. We read this step-by-step procedure, and then we do the problem. And this method is very simple. You need not to learn any separate for this, and you need not to remember any separate thing only. Whatever we have the methods of finding the solution of ordinary differential equations, we apply all those ordinary differential equation methods for this partial differential equation also, in the case of method of separation of variables. Right? Now we read the procedure on. Step-by-step procedure on. Step number 1. Factorize the dependent variable of a given partial differential equation into a product of two functions, comma, each of which is a function of one independent variable It is the first step. Let us suppose this equation. It is already a partial differential equation. In this partial differential equation, u is the dependent variable. Independent variables are x and y. So according to this first step, factorize the dependent variable u into a product of two functions, each of which must be a function of one independent variable. That is, u equal to f of x comma y should be written as function of x into function of y, or x of x into t of y, like this. We should write the dependent variable u as a product of two functions, each of which should be function of one independent variable only, like this. It is the first step. That is, u of x comma y equal to x of x into t of y. Step number 2. Step number 2. Substitute above. Let us suppose this is 1 above. That is 1 into given partial differential equation. Substitute above, that is equation 1, into given partial differential equation. Step number 3. Divide the resulting partial differential equation obtained in step number 2. Divide the resulting partial differential equation obtained in previous step, that is in step number 2, by x of x into t of y. This is the third step. Next, step number 4. Equate the resulting partial differential equation obtained in step number 3. Equate the resulting partial differential equation obtained in step number 3 to constant k. Constant k. And separate the ordinary differential equations. Step number 5. Solve the two ordinary differential equations for solutions x of x and t of y by ODE methods. Next, step number 6. Substitute the solutions x of x and t of y in the required solution u of x comma y equal to x of x into t of y, which gives the required general solution of partial differential equation. That's it. This is the method of separation of variables. Just we follow this procedure. So first we do one problem on this, And after that onwards, without doing the problem by this method, we try to choose answer by verification. But we should know the method. Actually, this method of separation of variables reduces partial differential equation into ordinary differential equation. The main aim of this method of separation of variables is reduction of partial to ordinary. So this method of separation of variables reduces the partial differential equation to ordinary differential equation. After reduction, we try to solve the ordinary differential equation by ordinary differential equation method only. That is, again, we require the ordinary differential equation methods only. In the previous classes, whatever we have discussed the methods of finding the solution of first order, first degree, and second and higher order, we require all those methods here only. That is why here you need not to remember any separate method only. Just follow this procedure. Again, we require the previous methods only. Okay, this is the procedure. Let us do one problem on this so that we can understand this. So we come to first step. What do we do? First, we identify the dependent variable, and we should write that as a product of two functions. And we substitute that in the given equation. After that, we equate first. Before that, equating the constant, we divide the equation with the product x into t, and then we equate that to constant. After that, we separate the ODs. And after getting the ODs, we solve the ODs by ODs methods, and we substitute x of x, t of y in the required solution u of x, y. Okay, let us go to the problems. The first problem, the solution of the partial differential equation dou u by dou t equal to alpha into dou square u by dou x square is of the form. Option A, C into cos kt. Option A, C into cos of kt. After this, within the brackets, C1 into e power under root of k by alpha into x plus C2 into e power minus under root of k by alpha into x. Option B, C into e power kt into C1 into e power under root of k by alpha into x plus C2 into e power minus under root of k by alpha into x. Next, option C, C into e power kt into C1 into cos of under root of k by alpha into x plus C2 into sine of minus under root of k by alpha into x. Option D, C into sine kt into C1 into cos of under root of k by alpha x plus C2 into sine of minus under root of k by alpha x. This is the problem. It is a given differential equation. Yesterday we have written this as an example of one of the type of the equation under classification. It is a one-dimensional heat equation, 1D heat equation. And we are asked to find the solution of this. That solution was given in the options. It is a civil gate question. It is a civil gate question because for you there is no gate question. That is why I took this problem from the civil previous gate questions. Now just look at the differential equation. In every term, there is a derivative only. If all terms are with the derivatives or dependent variable, then the equation must be homogeneous. And also a highest order derivative, second order. It is a second order homogeneous, and also linear, because power of the derivatives is 1. Second order linear homogeneous differential equation. In this differential equation, from the derivatives, if you observe the variables, u is the dependent variable and independent variables are x and t only. For this differential equation, writing the solution is as finding the u in terms of x and t satisfy the equation. Finding the dependent variable u in terms of independent variables x and t satisfy this equation. So according to our method, we write this as a product of two functions. That is, initially we separate the variables only. That is x of x into t of t. And we assume this as solution. And we try to find the solution of the equation. Okay, let us do this problem according to our step-by-step procedure. Solution given dou u by dou t equal to alpha into dou square u by dou x square. So this is 1. According to first step, we should write the u as a product of two functions. Each function should be a function of one independent variable only. So here u of x comma t is a required solution. But initially we write this as a function of one independent variable into again function of one independent variable. X of x into t of t like this one. Factorize the dependent variable u as a product of two functions, and each of which should be a function of one independent variable like this. So this 2. So finding the solution is same as finding the u in terms of x and t. That is same as finding the x of x, t of t only. So from this we require the solutions x of x and t of t only. Be the solution of equation 1. Next, according to the second step, we should substitute this in equation 1. Wherever u is there, in place of that, we substitute the x of x into t of t. Put 2 in 1. We get dou by dou t of x. Instead of writing the x of x, in short form, I write the capital X only. Instead of writing the t of t, I am writing the capital T, that's all. X into t equal to alpha into dou square by dou x square of x into t like this. Next, we divide this with the x into t, on the product x into t. But before that, we write the derivatives of this. In the very first class of the differential equation topic, already I told you that there are two types of derivatives that depends on the given relation or function only. If a function is a function of one independent variable, the derivatives are ordinary derivatives. For this function of one independent variable, derivative will be written as dy by dx, d square y by dx square, and so on, ordinary derivatives only. Suppose the function is a function of more than one variable, u equal to f of x comma y like this. Then the derivatives are partial derivatives only. Dou u by dou x, dou u by dou y, dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. If a function is a function of one independent variable, the derivatives are ordinary derivatives. If a function is a function of more than one independent variable, the derivatives are partial derivatives only. So there are only two types of derivatives based on number of independent variables. More than one independent variable, derivatives are partial. One independent variable function, derivatives are ordinary derivatives. Now, if we look at this, on left hand side, we require the dou by dou t of x into t only. But in the product of these two functions, x is a function of x variable, t is a function of variable t, and we are doing with respect to t only. So x of x is constant because it is a partial derivative. When you differentiate the function partially with respect to one variable, we treat other variable as constant only. So x is constant, then dou by dou t of t or t of t only. X of x into dou by dou t of t only. It is a function of one independent variable. For a function of one independent variable, derivatives are ordinary only. Actually, t is a function of one variable and dou by dou t is partial derivative. Even though it is partial derivative, because of the one independent variable, we can write this as dt of t by dt only. So both are same only. This partial is same as the ordinary only. Both are same because of the one independent variable function. That is why here we write the capital X into dt by dt. In short form, t dash only, which implies on left hand side x into t dash equal to alpha into similarly for second order derivative also. Here we are doing with respect to x only. T of t is constant because that is free from variable x only. Only x is a function of x. So we should differentiate capital X 2 times with respect to x only. T of t is constant. Derivative of this becomes dou square by dou x square of x of x becomes, this x of x is a function of one independent variable. Because of one independent variable, this partial is same as ordinary only. That's why we write this as d square capital X of x divided by dx square like this. Both are same one. So in short form, d square can be written as x double dash only. So we write this as, since t dash equal to d capital T by d small t and x double dash equal to d square capital X by d small x square. Whenever function is a function of one independent variable, the partial derivative of that one independent variable function is same as ordinary derivative. That is why we write the ordinary derivative in place of this partial. This ordinary in place of this. This ordinary in place of this partial. Now, next step is we divide both sides with the product x into t, which implies x into t dash divided by x into t equal to alpha into t into x double dash by x into t. Now after simplification, this becomes just t dash by t equal to alpha into x double dash by x. So variables are separable. All t's are one side, all x are one side. According to our next step, we equate this to some constant k only. We go to next page, which implies t dash by t equal to alpha into x double dash by x equal to constant. Say equate this to equate the resulting equation after dividing this to constant k. Here this constant may be greater than 0, less than 0, or equal to 0. 3 possibilities only. In particular, if you want to take, we can take 3 cases only. Next, after equating the both to constant k, we separate like this: t dash by t equal to constant k and alpha into x double dash by x equal to constant k only. Right? Now, the given partial differential equation is reduced to 2 ordinary differential equation. This is one ordinary differential equation, that to first order. This is one ordinary differential equation, second order. In the given differential equation, just look at, I'm writing this here, dou u by dou t equal to alpha into dou square u by dou x square. If you observe this equation, in this equation, we have 2 independent variables, one dependent variable. If the given partial differential equation contains 2 independent variables, this will be reduced to 2 ordinary differential equations only. Suppose there are 3 independent variables, the partial differential equation will be reduced to 3 ordinary differential equations only. The given partial differential equation is containing 2 independent variables. That is why this is reducing to like this only, 2 ODEs only. This will be reduced to 2 ODEs only. And we can tell the order of the ordinary differential equation also. Just look at this given partial differential equation. With respect to t, the highest order derivative is 1. With respect to independent variable x, the highest order derivative is 2 only. With respect to one of the independent variable t, highest order derivative in the differential equation is 1. That is why this differential equation will be reduced to first order ordinary differential equation in terms of t only. With respect to t, first order is the highest order derivative. That is why we got first order ODE down. And with respect to x, highest order derivative present in the differential equation is 2 only. That is second order. That is why this will be reduced to second order ODE. Suppose both sides if we have like this, dou square u by dou t square like this one. Both are second order. With respect to x second order, with respect to t also second order, then this will be reduced to 2 second order ODEs only. Suppose if we have like this, dou u by dou t equal to dou u by dou x. With respect to x, highest order derivative is first order. With respect to t, highest order derivative is first order. So this equation will be reduced to 2 ODs, and 2 ODs will be first order only. Right? Like this, we can tell the order of the equation also before reduction only. And we can tell the number of ODs also before reduction, just by observation of given partial only. Right? Okay. Up to here, reduction is completed only. After reduction, we can solve the ordinary differential equation by our ordinary differential equation methods only. One is first order, one is second order. To find the solution of first order, we use our first order, first degree methods. To find the solution of the second order, we use the second order differential equation methods only. Now we solve these two. 1 by t into d capital T by d small t equal to k. Because t dash means dt by dt on into 1 by t equal to k. And second order is x double dash equal to k by alpha into x, which implies this first order ordinary differential equation is just like this in terms of our usual variables. 1 by y dy by dx equal to k only. This is like this. Now we can tell the method for finding the solution of this. It is only function of y constant, function of x is 1, variables are separable. So we can solve this equation by variable separable method only. Here, integral 1 by t d capital T equal to k into integral d small t plus c dash. And here x double dash minus k by alpha into x equal to 0. On the other side, the second order differential equation is just like this only. Y double dash minus something into y equal to 0. This equation is like this only. Already we know the method of finding the solution of this equation. It is a homogeneous equation. For homogeneous equation, general solution is the yc. To find the yc, we require the roots. For getting the roots, we consider auxiliary equation only. Just like that, we solve this. But instead of y, here x is present. It is the only difference. Which implies log t equal to kt plus c dash. And here auxiliary equation is m square minus k by alpha equal to 0, which implies we require the solution t only. So write the t in terms of other terms. T equal to e power kt plus c dash. Here m equal to plus or minus root of k by alpha. Therefore, t of t equal to e power c dash is some constant. Let us suppose that is c into e power kt. Since e power c dash equal to c. This is one solution for first order. Another one is here x of x equal to, the roots are real and different. We are the linear combination of two independent solutions. C1 into e power under root of k by alpha into x plus C2 into e power minus under root of k by alpha into x. That's all. Our aim is finding the two solutions of ordinary differential equations on. We saw at the end, after getting these two, at the end we substitute these two in the required solution, u of x equal to x of x, t of t. Hence, u of x comma t equal to x of x into t of t equal to, in place of x of x, ready, c1 e power under root of k by alpha into x plus c2 into e power minus under root of k by alpha into x. Next, in place of t of t, c into e power kt is a general solution of 1. That's all. This is the method. So again, we go back and then we discuss about again once again. It is a given partial differential equation dou u by dou t equal to alpha dou square u by dou x square. It is a second order linear homogeneous partial differential equation. Whether it is first order or second order doesn't matter. We try to solve the homogeneous linear by this method of separation of variables. According to method of separation of variables, the given partial differential equation will be reduced to ordinary differential equation. Number of ordinary differential equations after reduction is same as number of independent variables present in the given partial. Right? Next, we can tell the order of the each ordinary differential equation before reduction only. In the differential equation, with respect to t, highest order derivative is first order. So after reduction, we get one ordinary differential equation in terms of t of order 1. In the given differential equation with respect to x, highest order derivative is second order. So after reduction, we get one second order ODE in terms of x. According to our first method, identify the dependent variable and write this as a product of two functions, each of which must be a function of one independent variable like this. And we substitute this in equation 1. We get like this. And we simplify this. Just like this. After that, we divide both with both sides with the product x into t on. And after simplification, on left hand side only function of t and its derivative. On right hand side only function of x, its derivative. Variables is separable. And we equate each of which to some constant like this. And we separate ODEs. So t dash by t, alpha x double dash by x, both will be equal to some constant only. Even if we equate these two also, again we get same thing only. So we got two ODEs and we solve these two by our ordinary methods. So here onwards to find the solution, again we require the previous ordinary differential equation methods. That is why for this method, you need not to remember any separate method only. We require only the previous known methods. That is why this is a simple method, right? But little bit lengthy only. Because of this lengthy, there is no gate question on partial differential equation for your branches only. Actually, it is a gate question of civil branch. It is a civil gate question only. And that this question was given for 1 mark. This was given for 1 mark. Still, the problem is not completed only. According to options, we are stopping here only because this solution was given in the options only. Actually, for k greater than 0, if we do the problem, we get one possible solution like this only. For k less than 0, if we do like this, we get one possible solution. K equal to 0, if we do like this, we get one possible solution. For each case, we get one possible solution. Out of 3 possible solutions, we choose the actual solution according to given physical conditions only. So still problem is not completed, but according to our given options, we stop here on that. That's it. This is about the method of separation of variables. Where it is heat equation, wave equation, Laplace equation, then same method only, because all these are linear homogeneous partial differential equations only. Right? Now already we know the method for writing the solution of the differential equation. From next onwards, we try to choose answer by verification instead of doing the problem in this way only. And that too, in this differential equation or in this problem, no condition was given. That's why we are stopping here on with arbitrary constants. Okay, let us go to the next problem. Problem number 2. Already I told you that in the year 2017, this is for IES. In the IES examination, we have only 4 years question papers: 2017, 2018, 2019, 2020. In the year 2017, 2 questions were given on differential equation topic. I am talking about only differential equation, and both are PDs. One PD question, again here also one PD question. In the year 2017, 2 questions were given. Each question carries 2 marks, 2 plus 2, 4 marks. In the year 18, from the differential equation topic, no question was given. Nil, no question. In the year 2019, 1 question was given on partial differential equation, that too, 1 partial differential equation question, 2 marks. In the year 2020, on the differential equation topic, only 1 question was given, that is from ordinary differential equations. So first I am writing this question. Now I am writing the second question as partial differential equation from the 2019 IES question. From the gate, no previous questions, only from IES we have the questions. So second problem is the IES 2019 question. (2019) IES question. It is a 2 marks problem. The solution of initial value problem dou u by dou x equal to 2 into dou u by dou t plus u, comma, where u of x comma 0 equal to 6 into e power minus 3x, comma, is. Now option A, u equal to 6 into e power minus 3x plus t. Option B, u equal to 6 into e power minus of 2x plus 2t. Option C, u equal to 6 into e power minus 3x plus 2t. Option D, u equal to 6 into e power minus of 3x minus 2t. Right? This is the problem. If we compare this with the previous first problem, it is only first order, and the previous problem is second order. And one more difference is, in the previous problem, that is in the first problem, just a differential equation was given, but here it is given along with the condition. So whenever condition is given, we get the particular solution. In every option, particular solution is given. Because of this, without doing this problem, like previous problem method, we try to choose answer by verification only. In the verification, we have 2 methods. One is using differential equation. We can choose answer by verification, that is LHS equal to RHS or not. And another one is using the condition. Using condition. Using condition, possible to choose answer, we can choose. Not possible, using the differential equation, we can choose the actual answer. Okay, let us do this problem by verification only. Okay, right. Now the given condition is u of x comma 0 equal to 6 e power minus 3x. That is, this is same as the, in the given differential equation, 2 independent variables are present, x and t only. U of x comma t equal to 6 into e power minus 3x at t equal to 0 not. This is the condition. Our condition is like this only. It is u of x comma t at t equal to 0 only. So in every option, we substitute t equal to 0. In every option, we substitute t equal to 0 and check any one option gives this function or not. First option, u of x comma t equal to 6 e power minus 3x plus t. If you substitute t equal to 0, this becomes u of x comma 0 equal to 6 into e power minus 3x. This is same as our given condition. That is, condition is satisfied with option A. Whenever condition satisfies with option A, this may be correct, may be correct. We cannot stop, we cannot choose this as correct answer because this condition may satisfy with more than one option also. So let us go to the next option, option B. From option B, the solution is u of x comma t equal to 6 into e power minus of 2x plus 2t. And from this u of x comma 0 equal to 6 into e power minus 2x. This is not same as our given condition. So B is wrong. Next, option C, u of x comma t equal to 6 into e power minus of 3x plus 2t. U of x comma 0 equal to, when you substitute equal to 0, this becomes 6 into e power minus 3x, same as the given condition. So the condition is satisfied with option C also. Condition satisfied with the A and also C. Next, we verify the option D. U of x comma t equal to 6 into e power minus of 3x minus 2t. U of x comma 0 equal to 6 e power minus 3x. So the condition is satisfied with more than one option except B. It is satisfied with A, C, D. So we are not in a position to choose the answer using condition. That is why we go to the other method. That is, we check LHS equal to RHS or not for the differential equation. Okay, method 2, you can consider for option A, LHS equal to dou u by dou x. Our u of x comma y from option A. From option A, u of x comma y equal to 6 into e power minus 3x plus t. This is option A function only. Its derivative with respect to x is 6 into minus 3 minus 18 e power minus 3x plus t. Next, RHS equal to, RHS of the differential equation is 2 into dou u by dou t plus u equal to 2 into, this function with respect to t is 6 into e power minus 3x plus t plus same function 6 into e power minus 3x plus t. 6 to 12, 12 plus 6, 18 is equal to 18, 18 into e power minus 3x plus t only. LHS is minus 18 times, RHS is plus 18 times. Both are not same. Here, LHS is not equal to RHS. The differential equation is not satisfied with the option A. So A is wrong. Then we check the option B only. Option B. From option B, already option, I think, option B is already eliminated by the condition. So you need not to check the option B. Then you have to go to the option C directly. Now from option C, u of x comma t equal to 6 into e power minus of 3x plus 2t. 6 e power minus 3x plus t on. Now from this LHS equal to dou u by dou x. With respect to x is minus 18 e power minus 3x plus 2t. Next, RHS equal to 2ut plus u. 2 into with respect to is, with respect to is 2, 6 minus 12 e power minus 3x plus 2t plus u is 6 into e power minus 3x plus 2t on. So this is equal to minus 24 plus 6 minus 18 e power minus of 3x plus 2t. So here LHS equal to RHS. The differential equation is satisfied with this particular solution. So we can stop, we can choose this as correct answer. Or if you want to verify, we can verify the next option. C is the correct answer. But here we cannot choose here, we verify the other option also. Option D, u of x comma t equal to 6 into e power minus 6 into e power minus of 3x minus 2t. LHS equal to ux with respect to x is minus 18 e power minus 3x minus 2t. RHS equal to 2ut plus u equal to 2 into with respect to t is minus 1 plus 12 e power minus of 3x minus 2t plus u is 6 into e power minus of 3x minus 2t equal to 24 plus this is with respect to t plus 24 6 with respect to t is minus 1 plus 6 to 12. This is not there. So 18 e power minus of 3x minus 2t. Here LHS is not equal to RHS. Therefore, option D is wrong. Hence, option C is correct. Okay, 2 into 2, right. So it is not same. Okay. So like this, we can choose answer by verification. Right? It is a 2019 IES question, 2 marks problem. So simple method is verification method. Instead of doing this problem by the first problem method, that is method of separation of variables, so we can choose answer by verification. Verification is simple on. Right? So one of the previous question is completed. This is completed. This is completed. Next, we go to this problem, 2017 previous question paper. Next, problem number 3. Third problem is the 2017 one. IES 2017 question, 2 marks problem. Because all IES questions are 2 marks problems only. The solution of the following partial differential equation: dou square u by dou x square equal to 9 dou square u by dou y square is option A, sine of 3x minus y, option B, 3x square plus y square, option C, sine of 3x minus 3y, option D, 3y square minus x square. According to our question paper, or pattern of the question paper, we have only single correct answer questions only, not more than one correct answer question. Now look at this partial differential equation. This is a second order linear homogeneous equation. If you want to find a solution, we can find a solution by method of separation of variables. But here, this question is given along with options. In every option, one of the particular solution is given. Because of particular solution, just we choose the answer by verification only. The differential equation satisfies with any one option, that is the correct answer. Suppose this differential equation satisfies with the very first particular solution, stop here. The differential equation doesn't satisfy with A, we go to the B option. Satisfies, we stop here. We take this as correct answer. Doesn't satisfy with the option B, B is wrong, then we go to next option like this one. So let us start with the first option. Option A, the solution is u of x comma y equal to sine of 3x minus y only. According to differential equation, we require the two second order derivatives with respect to both variables only, which implies ux, partial derivative of u with respect to x, sine derivative cos, again inner function derivative dou by dou x of 3x minus y equal to 3 into cos of 3x minus y, and u with respect to y equal to derivative sign is cos into dou by dou y of inner function, that is minus into cos of 3x minus y. Next we require the second order derivatives. Uxx equal to, ux is 3 into cos. Once again differentiate this. 339 minus 9 sine of 3x minus y. And uyy equal to cos derivative minus sine minus plus. Again from the inner function we are getting one more minus into sine of 3x minus y. So consider LHS part. LHS equal to uxx equal to minus 9 sine of 3x minus y, and RHS equal to 9 into uyy. 9 into uyy is minus sine of 3x minus y. Both are same. Here LHS equal to RHS. That is, the given differential equation is satisfied with the option A. Therefore, option A is correct. That's it. Because of the particular solution, the equation will satisfy with one of the solution only. You need not to verify other options. We can stop here. So with this, 2017 question is also completed. 2017 is completed. 2019 is completed. We do this partial later on. So this is about method of separation of variables only. So till now we have seen the method of finding the solution of homogeneous linear partial differential equation by method of separation of variables. But we have done one problem on method of the depending on the method, and we have done other two problems by verification method only, right? So we have done three problems out of three. First one is gate question of civil branch. Other two are second, third are IES questions. This is a 2 marks problem. Second also IES. All IES questions are 2 marks only. Okay, let us go to the next. In the solution of partial differential equation, linear homogeneous is completed. Next we go to the non-linear only. That only first order non-linear. In the solution of partial differential equation, first part is solution of homogeneous linear by method of separation variables. In the second part, we can see solution of first order non-linear only. Solution of first order non-linear partial differential equations. We will discuss the only shortcut methods for 4 types of first order non-linear. Now, first one. Type 1. Partial differential equation of the type f of p comma q equal to 0, where small p equal to dou z by dou x, comma small q equal to dou z by dou y for z equal to f of x comma y. For z equal to z of x comma y. For z equal to f of x comma y or z equal to z of x comma y, the first order derivatives are dou z by dou x, dou z by dou y. Instead of writing this dou z by dou x, we use a short form small p, and we use the standard notation for this q only. The standard notations p and q for dou z by dou x, dou z by dou y. Right? Now here, the first type is partial differential equation of the type f of p comma q equal to 0. That is, the partial differential equation contains only p and q's, no x, no y, no z. The differential equation will be free from three variables, x, y, z. The differential equation will contain only p and q only. That's all. This is the first type equation. For this type, we discussed about the method of finding the solution. All these are shortcut methods only. Solution procedure. Let f of p comma q equal to 0, so this 1, with the given partial differential equation or given first order non-linear partial differential equation. That is, the differential equation should contain only p and q. That is only derivatives only. It should not contain the variables x, y, z only. It is a content. So this type of equation comes under this case, or type 1 only. Consider p equal to a. So this 2, where a is an arbitrary constant. Is an arbitrary constant. Put 2 in 1. We get, in place of p, write the a. F of a comma q equal to 0. Next, series 3. Solve 3 for q in terms of a. That is, q equal to phi of a. Solve equation 3 for q in terms of a. Now we know the p and q only. P is the dou z by dou x, q is the dou z by dou y. But our aim is finding the solution. Finding the solution means z equal to z of x comma y or z equal to f of x comma y. But to find the solution, this one. To find the solution z in terms of other variables, consider dz equal to dou z by dou x into dx plus dou z by dou y. Consider dz equal dou z by dou x into dx plus dou z by dou y into dy. Our aim is find the solution z in terms of other variables. So to get z, we integrate both sides only, which implies in other form, short form, dz equal to p dx plus q dy. Already we know the p and q. We substitute both p and q from the above, and we integrate on, which implies dz equal to p in place of p a dx plus in place of q function of a dy. Integrate both sides. Integral of dz equal to integral of a dx plus integral of phi of a dy plus integral constant c or b. Anyone can take. I'm taking the b on. Therefore, integral of 1 with respect to z is z equal to a is constant. Integral of 1 with respect to x is x plus phi of a is constant. Integral of 1 with respect to y is y plus b. Is a complete solution of equation 1. It is a pressure. The given first order nonlinear contains only p and q terms, no x, no y, no z. Then we do the problem in this way on. Let us assume the p equal to some arbitrary constant, and we substitute that in equation and solve the equation for q in terms of a, and substitute p and q in this derivative form, this total differential formula. In this total differential formula, our aim is finding the z only. To find z, we consider this total differential only. It is a type 1. Now for this, we do one problem. After this, problem number 1. The solution of q equal to 3p square is the solution of q equal to 3p square. It is understood that p means dou z by dou x, q means dou z by dou y. Because of this p and q, the equation is in terms of p and q. It is a first order partial differential equation, but p means here dou z by dou x, and p square means dou z by dou x whole square. Because of this 2, because of this power 2 of the derivative, it is a nonlinear only. First order derivative, but with the degree 2 only. That's why it is a nonlinear first order partial differential equation. Just check the equation. Is it free from x, y, z or not? Is it containing only p and q or not? Right. This equation is containing only p and q. There is no x, there is no y, there is no z. So this equation comes under first type equation. The differential equation is containing only p and q. So let us do this problem according to that above method. Given q equal to 3p square. So this 1. To find a solution, let p equal to a. So this 2, comma, where a is an arbitrary constant. Arbitrary constant. Put 2 in 1. We get q equal to 3 into a square. So this 3. We solve it for q in terms of a, but from the equation directly it is in terms of a only. Q in terms of a directly. We have p in terms of a, q in terms of a only. We substitute both in our total differential only. To find the solution z in terms of x and y, consider dz equal to small p into dx plus small q into dy, which implies dz equal to p is a dx plus q is 3a square dy. And take the integration on both sides. Integral of dz equal to integral of a dx plus integral of 3a square dy plus integral constant b. Therefore, z equal to ax plus 3a square y plus b is a required solution of equation 1. It is a shortcut method, not a general method to write the solution of this. General method is lengthy only. That's why we are following the shortcut method. According to the shortcut method, just assume the arbitrary constant a in place of p and we substitute in the given equation. Try to get the q in terms of a and substitute both in the required this solution given by this partial derivative. So in place of this partial derivative p, we substitute a. In place of partial derivative q, we write the 3a square and we integrate on both sides. This will give the solution. This is first type. Next, second type. Type 2. Partial differential equation of the type or of the form f of p q z equal to 0. The previous type, the first type is only containing the differential equation is containing the p and q only, but this differential equation must contain p, q and z only. Should not contain the x and y. It is free from x and y. Previous is only p and q. It is f, p, q, z. Now we are the procedure on it. Let f of p comma q comma z equal to 0. So this one be the given first order non-linear partial differential equation. On our shortcut method, we do like this. Consider q equal to ap. So this 2, where a is an arbitrary constant. Put 2 in 1. We get f of, in place of q, we write the ap only. F of p comma ap comma z equal to 0. Solving 3 for p in terms of a and z, we get p equal to phi of a comma z. If you know the p, we can add the q, which implies q equal to a p equal to a into phi of a comma z. Now we know the q and p. We know the q and p. We substitute both in the total differential. To find the solution, that is z in terms of x and y, we consider like this. Consider dz equal to p dx plus q dy, which implies dz equal to, in place of derivative p, we have the phi of a comma z dx plus, in place of q, we have the a into phi of a z dy. Here it is a phi is a function of constant a and z variable. Here phi is a function of constant a and z variable only. But here the integral is with respect to x, here integral is with respect to y. Should not have function of z only. We bring the function of z to left side only. Therefore, integral of 1 by phi of a comma z dz equal to integral of dx plus a into integral of dy plus b gives the solution of 1. This is the procedure. Just try to get the p and q and substitute p and q in the total differential dz equal to p dx plus q dy and integrate. It is a method. This is for second type of the equation. Let us do the problem. The solution of p square z square plus q square equal to 1 is, if you observe the differential equation, this is containing only p, q and z. Power of p is 2, power of q is 2. That is, the power of the derivative is more than 1. That is why it is a nonlinear equation. This nonlinear equation is containing only p, q and z only, free from x and y. So this comes under second type. So to find the solution of this equation, we follow the previous procedure on. Let us do this problem. Given p square z square plus q square equal to 1. So this 1. According to our method, let us assume the q equal to AP. So this 2, where A is an arbitrary constant. Put 2 in 1. We get, in place of q, write the AP only. P square z square a square p square equal to 1. And we solve this equation for p in terms of other terms only. From each and every term, p square is common. P square into z square plus a square equal to 1, which implies p equal to plus or minus 1 divided by under root of a square plus z square, which implies q equal to AP plus or minus a divided by under root of a square plus z square. So we know the p and q. To find the z in terms of x and y, we consider the total differential. Consider dz equal to p dx plus q dy, which implies dz equal to, in place of p, plus or minus 1 by under root of a square plus z square dx plus or minus a by under root of a square plus z square dy. So from right hand side, we take the function of z as common, and we bring that to left hand side, which implies under root a square plus z square dz equal to plus or minus is common from both 1 dx plus a dy, and take the integration on both sides. Which implies integral of under root of a square plus z square dz equal to plus or minus integral of dx plus integral of a dy plus integral constant b. Therefore, on left hand side it is in the form of integral of under root of a square plus x square form only. That is x by 2. In place of x here we have z. So z by 2 into under root of a square plus x square. That is a square plus z square plus a square by 2 into sine h inverse of z by a, or log. You can add any one. This is equal to plus or minus integral of 1 with respect to x is x plus integral of a into with respect to y is y plus b is a required solution of 1. It is a method. This is the second type equation. First type equation is only P and Q in the differential equation. Second type is P, Q and also Z. Next we go to the next type. There are 4 types under shortcut methods for first order nonlinear differential equation. Out of 4, 2 are completed. We are going to next one. Type 3, partial differential equation of the form f of x comma p equal to g of y comma q, or f of x, y, p, q equal to 0. Now observe this equation. If we compare this with the previous 2 types, this is the equation with the x, y, p, q. So this equation is free from z. First one is only in terms of p and q. Second one is in terms of p, q and z. It is in terms of x, p, q, y, free from z. Read the procedure. Let f of x comma p equal to g of y comma q equal to a, comma, where a is an arbitrary constants. Then separate both. F of x comma p equal to a, and g of y comma q equal to a. We solve these two for p and q in terms of other term. Solving f in terms of x and z. Solving f for p in terms of a and x and g for q in terms of a and y. We get small p equal to capital F of a comma x and small q equal to capital G of a comma y. Now we know the p and q. We write the solution by taking the dz. Consider dz equal to p dx plus q dy, which implies dz equal to, in place of p, at the f of a comma x dx plus in place of q, at the g of a comma y. Therefore, integral, or at this, take the integral. Therefore, z equal to integral of capital F of a comma x dx plus integral of g of a comma y dy plus b integral constant gives the solution of 1. This is the third type. Just equate each of its two constant, arbitrary constant a, and separate. Solve both for p and q, substitute in the total differential. This result is called total differential of z equal to z of x comma y. We discussed about this method of writing the dz for this function of two variables in the calculus. Now, next we do the problem on this. The solution of p square plus q square equal to x plus y is equation is in terms of p and q, x, y. So first order nonlinear because of the first order derivatives with the power more than 1. And this nonlinear is containing the only x, y, p, q free from z. Because of this equation comes under third type only. Given p square plus q square equal to x plus y. So this one. But according to our method, we should add the p and x on one side, q and y on other side. Bring the x this side and shift the q square other side. And take the each of which equal to some arbitrary constant. Let p square minus x equal to y minus q square equal to a, comma, where a is an arbitrary constant. then p square minus x equal to a and y minus q square equal to a. We solve these two for p and q, which implies p equal to, we shift the minus x other side, a plus x, and power 1 by 2, or write the plus or minus under root of a plus x, and q equal to plus or minus under root of y minus a. We got p and q already. So to find the solution z in terms of x and y, consider total differential. Consider dz equal to p dx plus q dy, which implies dz equal to, in place of p, at the plus or minus under root of a plus x dx, plus or minus under root of y minus a dy. Integrate. Integral of dz equal to, from both plus or minus is common, into integral of under root of a plus x dx plus integral under root of y minus a dy plus integral constant beyond. Therefore, z equal to plus or minus root x derivative form, so root x integral on, or we can write the integral of a plus x power 1 by 2, just like x power n form. So a plus x power 1 by 2 plus 1, that is 3 by 2, divided by 3 by 2 plus y minus a power 3 by 2 divided by 3 by 2 plus b. Is a general solution. Sorry. Is a solution of 1. So it is a method of finding the solution of third type. Out of 4 types in the shortcut methods, we completed the 3 types. Now we are going to last type. On the last type, we have a IES gate question. So IES question, not gate one. On fourth type, we have a IES question. That question was given in the year 2017. Type 4. Partial differential equation of the form z equal to px plus qy plus f of p comma q. Name of this equation is Clairaut's form. Now this is Clairaut's form. For the procedure. Let z equal to px plus qy plus f of p comma q. So this one be the given partial differential equation, and it is called Clairaut's partial differential equation. It is called Clairaut's equation or Clairaut's partial differential equation. Very first one is just function in terms of p and q, or the equation is containing only p and q. Second type is p, q, and also z. Third type is f of x, y, p, q1. Or we write like this. f of p, q, x, y. Equation contains p and q, one method. Equation p, q, z, one method. Equation contains p, q, x, y only, then one method. And other type is f of p, q, x, y, z, all are there. But the differential equation should be in the form of z equal to px plus qy plus f of p and q only. This differential equation should be in the form of like this. If it is like this, we write the solution directly within one step only. Consider small p equal to a and small q equal to b. Where a and b are arbitrary constants. Using 2, 1 becomes z equal to ax plus by plus f of a comma b. So this thing here, equation 3 is a required solution. Solution 1. That's it. The equation is in this form, or Clairaut's equation. Within one step, we can write the solution just by replacing p by a, q by b. That's it. Z equal to px plus qy, f of p and q. Like that here, z equal to ax plus by plus f of a and b. By replacing p with a, q with p with a, q with b, p with a, q with b, directly we write the solution within one step. So we have a IES question on this type only. We do that problem. Now, before writing the IES question, we do the another problem on this type. Problem number 1. The solution of p minus q into z minus px minus qy equal to 1 is, it is in terms of p and q, so partial differential equation. That it is not containing only p and q, so it is not a this type. This is not this type. In this we have the x and y, so this is not in the form of p, q, z. This is not this type. Next, in this we have x, y, z also. So this is not in the form of p, q, x, y. This is not this type. So the equation is not in the form of any one of these. Next, we check whether this is in the form of z equal to px plus qy plus f of p comma q only. We check the given equation is in the form of this or not. If it is in the form of like this, within one step we can have the solution just by replacing p by a, q by b only. And also this is called Clairaut's equation. If we shift this p minus q other side, we get only function of p and q only. Again, if we shift the px other side, qy other side, then we get the z equal to px plus qy and function of p and q only. So directly it is in the form of this type only. So we write the solution just by replacing p by a, q by b only. Given p minus q into z minus p x minus q y equal to 1. So this one, which implies, we simplify this, z minus px minus qy equal to 1 by p minus q1, which implies z equal to px plus qy plus 1 by p minus q1. Clairaut's partial differential equation. Because of Clairaut's equation, we can write the solution. Therefore, z equal to ax plus by plus 1 by a minus b1. For p equal to a and q equal to b is a required solution of equation 1. Now next we write the other problem on this. The other problem is the IES question that was given in the year 2017. Now I am writing the IES question. Problem number 2. The complete integral of z minus px minus qy power 3 equal to pq plus 2 into p square plus q whole square is option A, z equal to ax plus by plus cube root of pq plus 2 into p square plus q whole square. Option B, z equal to ax plus by plus cube root of ab plus 2 into a square plus b whole square. Option C, z equal to ax plus by plus cube root of ab plus cube root of 2 into a square plus b whole square. Option D, z equal to ax plus by plus c. It is a 2017 IES. So we have done with this that 3 IES questions will be completed only. Later we do the other IES question, latest IES question. Given differential equation is like this: z minus px minus qy power 3 equal to pq plus 2 into p square plus q whole square. So this one. The equation is not in the form of f of p and q only, not in this form, not in the form of p, q, z, not in the form of p, q, x, y. So finally, the equation should be in the form of Clairaut's form. We check the equation is in Clairaut's form or not. On right hand side, only function of p and q only. On left hand side, we have z, p, x, q, y. If we shift the px and qy other side, we get the Clairaut's equation, which implies z minus px minus qy equal to, shift the power 3 other side, that becomes cube root of pq plus 2 into p square plus q whole square. Again, we shift these two terms other side, z equal to px plus qy plus cube root of pq plus 2 into p square plus q whole square. This is the Clairaut's equation. Now from this, we write the solution within one step just by replacing p by a and q by b only. Therefore, z equal to ax plus by plus cube root of ab plus 2 into a square plus b whole square. For p equal to a and q equal to b is a solution of 1 only. This is the 2017 IAS question. It's 2 marks problem. Right? So with this, the solution of partial differential equation part is completed already. We are in third part of the differential equation. Third part of the differential equation is partial differential equation. In partial differential equation, we have two subtopics. One is classification, other one is solution. Yesterday we have completed the classification. Today we have started the solution. In the solution also, again, we have two subtopics. One is solution of homogeneous linear partial differential equation. Other one is solution of first order nonlinear. In the solution of homogeneous linear differential equation, we have considered the method of separation of variables. In the solution of first order nonlinear, we have seen the 4 types of shortcut methods. On the fourth type, we have a IAS question. This is the IAS question. Now, after this, we do the one more problem from the IAS question. That is a 2020 IAS question. But in the year 2020, in the IAS examination, one question was given from this differential equation topic. That is from ordinary differential equations. With that, the total differential equation topic will be completed on it. IAS 2020 question. The solution of the differential equation 1 plus y square into dx plus minus of tan inverse of y minus x dy equal to 0 is. 4 options were given. Option A, option B, option C, option D. But I'm not writing these options. Now this is the 2020 IAS question only. That is a recent question only. So this question is from ordinary differential equation only. That too, first order, first degree differential equation, because it is in the form of like this. M dx plus n dy equal to 0. M dx plus n dy equal to 0. Now we can check one by one. For finding the solution of first order and first degree, we have seen these 6 methods only. The first one is variable separable, next homogeneous, next exact, next non-exact, linear, non-linear. We check one by one. In place of m, variables are separable, but in place of n, variables are not separable. So first method is not applicable on it. Next, m is not a homogeneous function. Second method is not applicable. Next, we check the exactness condition. M with respect to y is 2y. N with respect to x is minus plus 1. These two are not same, not exact. In the methods of finding the integrating factors, we have 5 methods. And this is not in the form of inspection form. Sorry. This is not in the form of inspection form. And it is not a homogeneous function, so first method fails. And this is not in the form of y into function of xy. So this method also fails. So instead of checking other two, we check whether it is linear or not only. Whether it is linear, non-linear. But to check the equation is in the form of linear or not, we should write this in the form of dy by dx only. Dy by dx equal to 1 plus y square divided by tan inverse of y minus x, like this. This we can write. But it is, y is a dependent variable. The dependent variable power is 2 more than 1. Therefore, it is non-linear term. That is why it is non-linear differential equation. It is not in the form of linear only. When it is not in linear in y, when it is not in the form of linear in y, we check whether the equation is linear in x or not. To check the linear in x or not, we should have variable x, its power should be 1. Here no x, but in this we have x, that to power of x is 1. So to write the linear in x, then we write the reverse order, dx by dy equal to minus of, and if we shift this other side, the minus becomes plus, no minus. So tan inverse of y minus x divided by 1 plus y square. X into function of y, other side function of y. So we write this as linear in x. The given equation is not linear in y, but it is linear in x only. So we try to do the problem by linear in x method only. Here is the solution. Given 1 plus y square dx equal to, we shift this other side, tan inverse of y minus x into dy. So we write this in linear form only. For this, we write the one of the standard form, dx by dy equal to tan inverse of y minus x divided by 1 plus y square, which implies dx by dy plus 1 by 1 plus y square into x equal to tan inverse of y divided by 1 plus y square. So this one, since it is in the form of dx by dy plus function of y into x equal to function of y. So this is the equation in variable x. That is, it is a linear equation variable x on. To find the solution of this, first we have to find the integrating factor. Here, integrating factor is given by e power integral of 1 by 1 plus y square dy equal to e power. Integral of 1 by 1 plus x square is tan inverse. So tan inverse of y. The general solution of 1 is given by dependent variable into integrating factor equal to integral of non-homogeneous part function is tan inverse of y by 1 plus y square into e power tan inverse of y dy plus c. So in two places we have tan inverse, but tan inverse derivative is 1 by 1 plus x square. So it is also present. Therefore, we take the substitution tan inverse of y equal to t1. Take tan inverse of y equal to t. Then this becomes 1 by 1 plus y square dy equal to dt. This substitution we write this. X into e power tan inverse of y equal to integral of 1 by 1 plus y square dy is dt only. And tan inverse is t only. So t into e power t dt plus c. This becomes t into e power t minus e power t plus c. But in place of t, we write the tan inverse of y. Therefore, x into e power tan inverse of y equal to, e power t is common, we write the outside, e power tan inverse of y into tan inverse of y minus 1 plus c is a required solution of 1. It is a 2020 IS question. So this total differential equation topic is completed. Also, we have done all the previous IES questions. Out of 4 IES previous questions, 3 are partial differential equation and 1 is ordinary differential equation. Differential equation. In this, we have the 3 parts. One is basic definitions. Second part is ordinary differential equation. Third part is partial differential equation. In these basic definitions, we have seen the 8 definitions, 2, 3, 4, 5, 6, 7, 8, 8 definitions. In the OD, we have seen 4 subtopics. One is solution, next one type solution, next first order and first degree differential equation, next second and higher order linear differential equations. For gate point of view, these 2 are important. First 2 are important. But for IS, I cannot say important. You have to prepare all, because we have the previous year's questions on PD and OD in the IS examination. But for gate point of view, we have questions only from first 2. Till now, there is no gate question from PD for EC branch. But for instrumentation, there was only one gate question, that too on classification. Yesterday, we have done that problem. In the partial differential equation, we have seen the 2 topics. One is classification, other one is solution. In the solution, linear, non-linear. With this, the total differential equation topic is completed on. With this, I stop here. I close the session. If you have any doubts, you can send your question to this WhatsApp number. I'm giving the WhatsApp number 9848905004. Send your doubt question to this WhatsApp number. If you have any doubts on this topic. 9848905004. With this, differential equation topic is completed. For mathematics subject in our institute, we have many faculty. So for each topic, one faculty may come, or one faculty can take all topics. But here I deal all other topics except probability only. I won't deal probability. Except probability, I deal all other topics only. Based on the schedule, we come only and we'll take the topic on. But if I start one topic, then I will complete the topic only. I started the differential equation, so I completed the differential equation topic. So different teachers may take different topics, or one teacher may take all topics, one teacher may take half of the syllabus also. That depends on the schedule. So with this, I'm closing this session. We can send your doubt questions to this WhatsApp number. And I will spare some more time for doubt session here up to 4:30. You can ask the doubts also in this doubt session, or later you can send the doubt question to that number also. Okay, I am closing this session. Next, we start the doubt session. Okay, let us go to the doubt session. Hello.
Good evening, sir.
Good evening. Tell me your doubt.
Page number 5.
Page number 5. Okay.
Sir, here you told that based upon K, the answers will differ. But K is a constant, na, sir. How the answers will differ, sir?
No, here I wrote that K is greater than 0, less than 0, equal to 0 only. If I take the K positive here, then we get the plus K here only. If I take the K as negative, then here this will be negative. If it is negative, the answer will differ. Suppose K is negative, let us suppose. K is negative means here we should take the K equal to minus P square. Yes, whatever the value of P, this becomes negative only. So if I take the K as negative, this equation becomes m square, that becomes plus. If it is plus, then we get the imaginary roots only. Then we get the cos and sine only. That is a problem. Suppose K equal to 0, what do you get here?
Okay, sir.
Dt by dt equal to 0 directly. Solution will be different. Okay?
Okay, sir. Okay.
Next. Hello?
Hello, sir. Sir, 9F, sir.
9F.
Sir, here, how dz equal to adx plus phi of a comma dx, sir?
Which one?
Side.
Phi of a. Here?
dz equal to adx plus phi of a dy. Side you wrote, no, sir.
dz equal to dou z by dou x dx plus dou z by dy d, right?
Side another point you wrote, no, sir. Yes, sir, that formula only.
Or this one, dz equal to p dx plus q dy.
Sir, is the formula, sir, or we can?
This one. Actually, we will discuss about this total derivative, total differential in the another subtopic of mathematics, that is calculus. In the calculus, we have many subtopics. One of the subtopic is partial and partial derivatives. In that partial derivatives, we discuss about the total derivative, total differential.
This one is formula, inbuilt formula, sir?
This is formula.
Okay, sir.
To find the z with a known p and q, we consider this type of. This is called total differential of function of two variables.
Okay, sir. Thank you, sir.
Hello?
Hello? Yes, sir, I have 2 doubts.
Okay.
So, questions, I have 2 doubts in questions.
Which one?
Questions are d square plus 9 into y.
Should I write?
Yes, sir. D square plus 9 into y.
D square y.
No, sir, that operator d.
Okay, d square
plus 9.
Plus 9.
Y. Whole y. So that bracket y is equal to sec 3x, secant 3x.
Okay. For this, we have to follow a general method.
Okay, by general method.
General method, or method of variation of parameter. D1 we can take.
Oh, means D we have to convert to dy by dx, like that.
It is a second order equation. We can do this problem by general method or method of variation of parameters. Method of variation of
Yes, sir. Okay, understood. So one more question.
uh,
Consider a differential equation.
hmm,
One equation is given.
hmm.
Then it is told to find, consider a differential equation. Then the two linearly independent solutions of the differential equation are given by dash. So means we have to find the two linearly independent solution. How we find that?
For homogeneous linear differential equation, complementary function is a linear combination of independent solutions. So for homogeneous equation, to find the independent solutions or non-homogeneous equation, first we consider the auxiliary equation, f of m equals 0. We solve it for roots. Depending on the roots, we write the linear combination. That is, which are the independent solutions. Suppose if it is second order, then we'll have a two roots, m equal to m1, m2. Suppose real and different, then y1 equal to e power m1x, y2 equal to e power m2x. These two are two linearly independent solutions. And we write the yc as yc equal to c1 e power m1x plus c2 e power m2x. It is a method of finding the independent solutions. Third order.
Then the independent solutions, two means there are two independent solutions. One is e to the power m1x and one is e to the power m2x.
That's it. When the roots are real and different.
Yes, sir.
Suppose repeated, then c1 e power m1x plus c2 x into e power m2x.
Yes, sir.
Got it?
Yes, sir. Can you once explain in short Euler-Cauchy's?
Short method.
No, sir. Once you can explain Euler's Cauchy's in short, means brief it.
Okay. X power n d power n y by dx power n plus p1 into x power n minus 1 d power n minus 1 y by dx power n minus 2 plus and so on plus p n minus 1 x dy by dx plus p n y equal to qr. Here all p's are constants. Even though p's are constants, because of this function of independent variable as a quotient of derivative, this is a variable quotient. But every variable quotient may not be a Cauchy-Euler. There is some condition. In the variable quotient equation, in every term, the power of x is same as order of the derivative. The power of x is same as order of the derivative. The power of x is same as order of the derivative. Then only such a variable equation is called Cauchy-Euler or Euler-Cauchy equation. And it is a special equation. Why it is special means this can be reduced to linear differential equation with the constant quotients. This variable quotients will be reduced to constant quotients by the transformation. If the transformation is x equal to e power z or log x equal to z. Similarly, we replace the derivatives like this: x d with theta, x square d square with theta into theta minus 1, x cube d cube equal to theta into theta minus 1, theta minus 2, and so on. With this substitution, this will be reduced to constant quotients. Once.
So we can either put x is equal to e to the power z or x d is equal to theta. Means either of that.
No, both. We should separate. This is derivative only. Because it is a transformation. Whenever we introduce some new variable z, then we have to change the dy by dx. Correct or not? We should change dy by dx. So we have already these two variables in the equation, but we are introducing some new variable. So dy by dx equal to dy by dz, dz by dx only. But from this, dz by dx is 1 by x only. Dy by dz into 1 by x. Derivative of z with respect to x is 1 by x only. If we bring this side, that becomes x. So in place of x dy by dx, we write the dy by dz. So that this variable will be eliminated. We get only constant quotient on. In short, we are writing xd equal to theta only. Because we are using the notation capital D for d by dx. In the same way, for d by dz, we are using the theta only.
Thank you, sir.
Right?
Yes, sir.
All doubts are over?
Yes, yes.
Hello?
Hello, good evening, sir.
Hello, good evening.
Hello.
Good evening.
Sir, I am electronics student.
Okay.
Hello.
I'm audible.
Euler-Cauchy's differential equation is important for electronics, sir.
Yeah. For both branches important. Because we have the gate questions on this Euler also.
And only partial differential equations are not important, sir.
Oh, no, in gate point of view.
Yes,
Only
sir.
for- But
For gate, till
for-
ordinary equations,
tell me.
till ordinary equations, if we do means it is enough, sir.
Enough. But remember one thing. Up to 2020 from 1993, no question only.
Okay.
In future,
Sir.
if we get a question also, that question may come from class question or method of separation variables only. So class question is not a difficult topic. Just should remember the condition only. B square minus 4AC. So we can remember that also. Next, method of separation variables also not difficult only. Just
sir.
we assume, substitute, simplify. So that we get the ordinary differential equation. We solve the ordinary differential equation by our ordinary methods only. So you need not to remember separate any other method only. That's it. Just remember these two at least in partial only.
Okay, sir.
Okay? Right.
Sir, actually in some particular integrals methods, there are some lengthy processes, sir.
Yeah.
Is that the procedure for solving those? If they ask complete solution, we need to find both the solutions, right, sir? YC and YP.
YC plus YP.
So that is the only method, sir, for those things.
Yeah. That is only one method. That is why from the non-homogeneous also we have very few gate question. The two on first case, second case, third case only.
Okay, sir.
It is a reason only.
Sir, your teaching is very nice, sir.
Thank you.
Okay, sir. Thank you, sir.
Welcome. Okay, I'm closing this doubt session also.